Hey everyone, this is Scott from Pomerol Partners. I've been asked many questions recently about the Writeback in Qlik Sense and how it actually works on the back end. These are questions like, what if multiple people are trying to write back at the same time? How do the updates actually get back into my app in memory? Lots of questions around performance, how does the Writeback work with large applications, and also about tracking user history and what do we do if we need full visibility of that. So we love answering these types of questions because while some of these items don't matter for getting started with simple use cases, they become very important in a production enterprise environment. And that's what our product has been built for. So in today's video, I'll show you what the data writeback process looks like, and we'll highlight a few pieces of governance and functionality that make the workflow robust and enterprise ready. Now, the easiest way to do this is with a use case. So let's take a scenario where we have a customer selling building supplies. There's variances between expected billing and actual invoices being sent to customers. And accounts receivable and account managers are using Qlik to spot those variances. They're then using the writeback to comment on those variances and assign actions to fix them. So the first topic here is concurrent usage. Multiple users can all be logged into their own Qlik session and be making updates with the Writeback extension at the same time. When the user wants to save their edits, they hit save, and the Node app that sits on the Qlik server passes their edits into SQL queries. So there's two things to note here. We've got multiple concurrent threads and they're handled natively by the SQL database, so there's no conflict as users try to commit their edits. But what's really important here is that the data edits are stored into two separate tables. Separating the data like this means when we come to load it back into Qlik, we can ignore the history if we wish. And this significantly optimizes the partial reload time because we can focus our load on the data table that contains just the latest edits. As soon as the data is committed to the SQL database, a confirmation is sent so that the Qlik server knows it's time to do a partial reload and pull this new information back into memory. At this point, we have a reload checker verify if the app is currently being reloaded. If it is, the reload the user has requested will be held in a queue until the app is available to be reloaded via the API. The next critical piece in this process is the partial reload. So Qlik gives us the ability to reload just a portion of our data model. This is especially helpful where we have a large data set held in memory, and we're only looking to update or add a few values to that data model. We might have a transaction table with 30 million rows, but we're only adding comments against a few of these transactions. We can partially reload to leave that main transaction table where it is and just reload the comments beside those 650 transactions that we're wanting to add a comment to. All users logged into the app will see the latest updates as soon as they become available. This is especially important for large user groups collaborating on a business process in Qlik. So as an example, on the left side here, we have an account manager making updates. And then on the right side, we have an employee in finance who's seeing those updates only a few seconds after they were entered by the account manager. So this whole workflow is live, and that's what really drives the collaboration. The final component I wanted to show off as part of this workflow is the audit log. So if we choose to load in our history table from the SQL database, we can see an audit trail of every edit made. This is not only great for auditing purposes, but for visualizing a negotiation or settlement process, or for identifying a prior version of edits that we might want to roll back to. So just as a quick overview of the writeback process we've just covered, we've got multiple users. They can all add edits and make updates concurrently. Those concurrent threads are managed natively by the SQL server, and when we hold and store that data, we split it into those two tables for optimal storage and for optimal loading back into Qlik. The automated queuing mechanism that ensures that the Qlik app can partially reload multiple times without any conflict. And it's that quick partial reload that really drives the user experience. And our rule of thumb here is that Users should be able to make edits, and they shouldn't wait more than a few seconds for those to be captured and loaded back in. And the final piece is that real-time updating that's so valuable for these large user groups that are collaborating on a business process within Qlik. So I hope this explains what's happening with the Writeback behind the scenes. Please get in touch with Pomerol with questions or for a live demo, and stay tuned to LinkedIn and YouTube for more videos like this answering your questions.